Welcome to Hope Academy. My name is Mr. O, and today I'm going to be going over questions number 31 through 33 on the SAT Math Level 2 Crack SAT Practice Exam 1. So when I usually do these problems, I go over them quickly and then I explain in depth how to do each problem carefully. And so I'm going to go ahead and get started. So for number 31, so keep and ignore this. This is just from prior questions I did in prior videos. What's a bond? Okay. So imagine as if there's a cube here. Okay. And there's a right in the speed radius 6. So there's something like 6 here. And here and here. Okay. This is x. Certain. X 2, but that same length is no. Okay. So So I'm going to go ahead and get the calculator just so I can solve this out. Times 2 cubed. So, that's not going to help me. So let's do this way then. Let's go 12 times 2. So that's going to be this cubed. Okay. So for number 31, my final answer is D, and now I'm going to explain to you how I was able to get this question. So when I am doing this type of question, the big important thing you must understand for this question is that it's so important for you to be able to visualize this problem, because this type of concept, and I'm going to go ahead and copy just like the basic idea of the question, is that this is based around the premise of what we would call volume questions, okay? And so I'm going to go ahead and write that, volume. Especially for this question, it's a bit tricky to visualize it because the question is basically asking that it's a cube, and I'm going to go ahead and draw a basic cube on this chart so you could see in a bigger grand scales of things what I was thinking of, but I did it really quickly. And so imagine if there's like a cube like this, and they're saying it's inscribed in a sphere. And so in a different color, and I'm going to take pink just because it will be easier to visualize. Imagine as if there is a cube. There's a sphere surrounding this cube, and it sort of looks like this. And do note that you don't need to add this circular things. It's just that I want you to be able to visualize it. And the important thing it mentions is that this cube that's in the inscribed, which means that it's inside the sphere, has a radius of 6. And what does that mean? That means that if you imagine shoving a cube into the sphere, that means that the corners are going to be here. The corners are going to be touching this sphere. And so we have to imagine as if in order to use that information that the sphere has a radius of 6, we have to imagine if the center of the cube right here until one of the corners, and I chose this corner, it doesn't matter which corner you use, will be a length of 6. That is the important thing you must first understand. But to continue on, I'm going to actually emphasize one aspect of this. So I'm going to go ahead and draw the bottom part of this cube as if you could actually see visually what's going on. And this is where the key information or the complexity comes in based on this question. So after we have this cube and the sphere and whatever not, the key important thing you have to understand is that the triangle, I need to create a triangle because that's the only way I could get the length needed in order to eventually get the length of a side of this cube. And you cannot make assumptions around this triangle. You can't assume that this is going to be a special triangle like a 45, 45, 90 or 30, 60, 90 triangle, because these type of questions, they don't end up being that case. Almost always it will not be that case. It will be some sort of triangle that goes to the bottom right here of this sphere, the bottom base of this, the cone, not cone, of the cube is going to be the bottom base of this cube, and it's going to go up to here. And we could imagine if there's a right triangle right here. Okay, we know there's a right triangle, but we don't know the other two angles, and we can't make assumptions here. What we do know, though, is the fact that when we are working with another possible triangle right here, and I'm going to use a different color for this, we could imagine as if this triangle right here is also a component of another triangle on the base of this cube. And so right here, there's another right triangle right here on the base of that cube, if you can see it right here in this color. So I'll maybe trace it out a little bit better so you could actually see it where it's at. There's another right triangle here. But this triangle right here, because we are splitting right in half of this base cube, will be a 45, 45, 90 triangle. We can make that statement true. Okay, and so right here, I know it's going to be x, right? This is length going to be x. This length is going to be x. So like x right here, x, and it's going to be x root 2. I'm able to find this little piece. But what's also great about me knowing these measurements on this base right here of xx is that when I have x root 2, right here, this hovering height is actually for certain going to be half the height of this whole cube, or aka half of one of the sides. This is not an assumption at all. This is a fact, because we're trying to, this is going to be a part of the radius of this whole sphere. And so right here, going from here to here is half of this cube. So this is also going to be x. And then now I could actually solve for x to help me solve this question now. Because now that I have this very quintessential information, now I could use the Pythagorean theorem. Okay, and so I'm going to write that term. Pythagorean theorem. And how Pythagorean theorem works is the basic idea of a squared plus b squared equals to c squared. But right here, for this question, because it's the right triangle right here, I could use x squared, and so I'm going to go ahead and do it in this color, the x squared plus x square root 2 squared equals to 6 squared. Make sure you follow along and make sure you know that the 6 is going to be my hypotenuse, or these are my two sides. And so thus, if you're solving this out, I'm just going to go through it real quickly on that part. It will be 2x squared equals to 36, 3x squared equals to 36. X squared is going to equal to, and I've divided by 3 on both sides, will be 12. And I can square root both sides. Thus, I know that x is going to be something like 2 root 3. Okay? But this type of question is not done when we find x. This question actually gets onto another level of complexity in a sense, because what actually happens is that once I'm able to find this value of x, that only finds me a half of one side of this cube. So technically, to find a whole side of this, I need to multiply this whole thing by 2, which will eventually get me to the actual side length of one of this, the one side of this cube. Now, the question doesn't ask me just to find one side of the cube. It asks me, what is the volume of the cube? And thus why what I need to do is that after having one side of a cube, I need to cube this whole thing. Eventually, you'll get 192 root 3. And I did punch this into the calculator to find it. You could do whatever method you need. And thus how, when I was doing this question, I was able to confirm that my final answer for number 31 is D. 192 square root 3, and that concludes my explanation for number 31. Now I'm going to continue on to number 32. So number 32. Alright, so I'm going to okay. So okay. That's going to be half of it. Okay. Okay, that's one equation. Okay, so 8, 20, 24. Okay. So this is going to be okay, 7. So for number 32, my final answer is E. And now I'm going to go ahead and explain how I was able to do this question. So when I was doing this question, it is another type of, it's similar in nature to the prior question, but not exactly, because this problem does play into a little bit more into depth around volume concepts and does play into sort of the ratio idea behind it. And so I'm going to go ahead on a separate piece of paper so to show how I worked this question out. And I'm going to remove this paper because I do not need this anymore. So when I'm doing this type of question like number 32, this is what I did. So first thing first, it's always important when I'm doing these volume type of questions to sort of visualize the question. And so it tells me, the question tells me that it is a right circular cone. And it tells me that it has a height of h and a radius of r. And so I'm going to go ahead and draw that out. And as I mentioned before, this is a volume question. So I'm going to write volume. Okay? And so when I'm doing this type of question, it mentions that if the cone is cut into two pieces by a plane that passes through the midpoint means the middle center area of this cone. So there's a plane that's chopping through this, it's just cutting through this. So imagine as if there's a little cone right here that exists right here for the cone, and what happens is that the different values for this little cone will be h over 2 and r over 2 because it cut through. So I'm going to do different colors so you could be able to visualize that, okay? And then afterwards, now that I have these different values, these values that I have, it's asking me what is the difference between the volume of the larger of the two results, so the volume of this piece right here, and this piece right here. What is the difference basically, okay? And so this is how I was able to go about doing so. So like the bigger piece and the smaller piece. So I know that my volume equation for this whole cone will be 1/3 pi r squared h, okay? And so what happens is that in order to find the volume of this piece right here, I need to do is get the area of this whole thing, subtract this area, this little cone right here. And so I'm going to go ahead and do so. So this is my volume for the large cone, the big cone right here. This is my equation. But I also need to find an equation for this. And so by doing so, I'm going to create another equation right here that follows that rule. So the volume for the smaller cone, and I'm going to remove this so the Sharpie doesn't bleed through. But the volume for the smaller cone is going to be volume equals to 1/3 pi. And now the r is going to be r over 2 squared h over 2. Because the h over 2 is the smaller height of the smaller cone, and the r over 2 is the smaller radius of the smaller cone. And so now I'm going to simplify this part right here. So it's going to be v equals to 1/3 pi r squared over 4 times h over 2. And if you combine all of this, what's going to happen is that it's going to be 8 times 3 to 24. So that ends up becoming pi r squared h over 24. This is the volume of the smaller cone right here. This part right here is the volume. But I am not done because the question is asking me what is the volume of this bigger piece right here. Thus, I need to take this and combine it. And thus, that's my next step. So I'm going to do is combine 1/3 pi r squared h, which is the bigger one, subtracted by this, pi r squared h over 24. And the way I'm able to combine these together is by finding common denominator. Since right now my denominator is 3 here, but 24 here, what I'm going to do is multiply this 8 over 8. Because what this does is I'm technically multiplying by 1, but it lets me create the common denominator. Okay, now I'll write that term, common denominator, just in case you want to look it up or look into it more. And so what happens is that it's going to be 8 pi r squared h over 24 minus pi r squared h over 24. Since these two have the same terminology, it'll end up becoming 7 pi r squared h over 24. And thus, when I was doing this problem, it ends up becoming E, 7 pi r squared h. And that concludes my explanation for number 32. And to continue on to the last question for today. So number 33. If e to the x does not equal to 1, e squared. Okay. So for this question, number 33, I'm actually going to just do this on the calculator because it makes it a little easier for me. So I'm going to do solve catalog e to x squared equals to 1 divided by square root 3 the power of x comma x. So my final answer is going to be B. Okay, so for number 33. So for this question, I'm going to show both the calculator way and the non-calculator way in order to solve this question. Personally for me, I realized when I looked at this question that it would be a lot easier for me just to do it on the calculator and saves me a lot of time. And thus, you choose based on your preference. So the calculator way, what I basically did was I used the TI-89 because personally for me, TI-89 is the fastest way to solve these questions. But I used a function called the solve function. Okay, so how to find it is that basically when you're turning on this calculator and whatever not, you're gonna go home, of course, and then you're gonna click the F1, and you could go to the next using the right arrow key. You go find the solve function as the first one. You're gonna push enter. Afterwards, I basically just typed down this equation exactly word by word. Be careful that you don't mess up on it, because sometimes based on certain questions, you might need more parentheses and certain things to make sure it doesn't, you're not solving for a different equation. And so that's what I basically did. I looked in the catalog for E, I believe. And so I pushed catalog, and then I pushed the letter E on the alphabet system right here. If you see in the white letters A, B, C, D, and I pushed E, it jumps me to E. And so I could do E to the X squared and type that out. And push equals to, there's an equals symbol right here on the calculator, equals to 1 divided by, and I typed square root of 3 to the power of X. And then after I wrote all that, which is the equation, I put comma X, because when I put that comma X, it means that I'm telling the calculator that please solve for X, solve for this specific variable. I close the parentheses, and that's how I was able to get to this answer. But the problem was that when it prints out, it will give me the ln version, and thus I push the green button, enter, and it gives me the decimal version afterwards. And so that's how I was able to do it on the calculator. Now for me to explain to you how to do it if you do not have the TI-89 or have that functionality available to you. And so when you're doing this type of question, and I see e to the x squared, and I see these powers up in the exponents and values and whatever not, I know as a fact I need to use the logarithmic concept. Okay, so logarithms are definitely the main concept for this question. But that being stated, in order to use logarithms, we need to simplify this statement as much as possible before we could even apply the logarithms. So that's what I'm going to do. So I put e to the x squared equals to, I'm going to first do is change this to a statement rather than having fractions. I don't like fractions personally, and so I'm going to change to square root 3 to the negative x power, because that's the same statement, just now in one line without any fractions. Afterwards, now I'm going to apply ln, because what ln does is it's like log, but what happens is that it lets me cancel out this. So I'm going to ln both sides like this. So I'm going to do ln basically. And what's going to happen is that because of power rule, and this is a terminology for logarithms, because of power rule, it lets me bring x squared down. And so right here, this x squared is going to come down. It's going to be x squared ln e equals to negative x ln square root 3. And what's going to happen, as I mentioned, ln e cancels out. Thus, what I basically have, and I should use a different color just to indicate that I'm going to the next step, basically. What's going to happen is that it's going to become x squared equals to negative x ln square root 3. And then if I want to move it all to one side and whatever not, my full statement actually is going to be x squared plus x ln square root 3 equals to 0. And the significance behind this statement, why I'm able to get to this statement, the reason why this is so important is because now I could factor or look for common denominators. I mean, not common denominators, but common factors. And thus, I could factor this to be x plus ln square root 3 equals to 0. And thus, I could solve for each component of this equation and help myself, solve it out. So I know that x is going to equal to 0. So x is going to equal to 0, but x plus ln square root 3 is also going to equal 0. I can move it over, so x equals to negative ln square root 3. And then, if I want to type that out, negative ln, so I'm going to go catalogs, push L, and other calculators will have it more readily available, ln square root 3, and I'm going to get that exact same answer. And thus how, for number 33, I got B. And that concludes my explanations for today. Thank you so much for watching this video. Please do subscribe to our YouTube channel, like our Facebook page, or follow us on Twitter so that we could continue to make content like this. I hope you have a wonderful day.